just briefly 3 sections only. I will start with a general introduction about who we are. Then, of course, I will look into a general overview of this program, SEISMOBUILD 2020, which is the latest edition for this year. And also, last but not least, will be our seismic evaluations on the 2-story reinforced concrete buildings, which is our tutorial for today. All right, as a start, who we are, who is Wallingford Consultancy? Actually, we are the solution providers to the architecture, engineering, and construction industry in the Southeast Asia regions. So our services actually provide into 3 main areas, which is into the software solutions. We provide trainings, and time to time, based on our private client requirements, sometimes we also offer a lot of consultancy services as well. We currently are distributor of some of the few solutions. One of them is a SEISMOBUILD. SEISMOSoft, which is the company. We currently, the developer is the distributions of the SEISMOSoft product in the whole Southeast Asia. All right. I would like to give a general overview about SEISMOBUILD 2020. So SEISMOBUILD actually is basically developed by a company called SEISMOSoft, based in Italy. So SEISMOSoft is actually recognized as one of the leading provider of earthquake engineering software solutions. So they develop very specialized type of software applications for analysis of structures, some subjected to seismic actions. Some of the software products consist of, like, of course, today is a SEISMOBUILD that we're going to discuss, but they also got other product line, for instance, like SEISMOStruct, SEISMOSelect, SEISMOSignal, SEISMOMatch, Artif, and SEISMOStack. There's a few of them. So they are considered as one of the very leading provider of earthquake engineering solution, software solution in the world. So today, in particular, I will look into SEISMOBUILD. Because SEISMOBUILD itself is a finite element software, specially dedicated to 3D modeling, seismic assessment, and strengthening of reinforced concrete structures. So, that's why I say it's a very innovative finite element program. And this program is built from the base of the origin program, our main program, which is SEISMOStruct. All right. So SEISMOBUILD are specially designed to design this software, especially target for the normal design office. Because we understand that during nonlinear analysis can be quite challenging for normal design office. Most of the time, nonlinear analysis are especially maybe in the research institute or university, people love to use nonlinear analysis to solving problems. But design office, they might not have time to really go into a very detailed testing different type of parameters. So this is the reason why SEISMOBUILD is born, especially target for design office. And in this program, SEISMOBUILD there will be a lot of presetting parameters already presetting for you. That means you no need to do all the testing or all the parameters, especially make the job for the normal design office to dealing nonlinear analysis a lot easier. And this program actually is very, very powerful because it's based on our original program, SEISMOStruct server algorithm. It's very powerful, but yet it's very, very affordable. If you compare to some of the mainstream program that are able to do nonlinear analysis, our cost is a lot more affordable. And we are exclusively, SEISMOBUILD are exclusively for seismic assessment and retrofitting of reinforced concrete beams. Actually, our programs, we are 100% performance-based seismic evaluation, seismic assessments. All right. And then we are the only software in the world that are focusing on seismic assessment and retrofitting, especially retrofitting, and also apply on strengthening intervention of reinforced concrete building structures. And also, we are also, most importantly, we are capable of conducting code-defined assessment methodology. What I mean by code-defined methodology is, in SEISMOBUILD, we are including all the major international codes in seismic evaluations. We have some of the this list here showing there's a 5 international standards or codes that is already implemented in a SEISMOBUILD, which is Eurocode 8 Part 3 for assessment and retrofitting of buildings. And of course, the American standards, ASCE 41, a very specialized type of code, especially for seismic evaluations and retrofitting existing buildings. And of course, the Italian National Seismic Code, NTC code for 08 and 18, and the Greek Seismic Intervention Code, and the Turkish Seismic Evaluation Building Codes. All right, so these are 5 main codes that international codes is in our SEISMOBUILD programs. So, so basically, this program, as what I mentioned, is based on nonlinear analysis software solver. So, taking into account 2 aspects, which is during nonlinear analysis, of course, is most obviously is the geometric nonlinearity, and secondly is the material inelasticity. So this program, as what I mentioned just now, is built based on a very, very powerful our program called SEISMOBUILD. It's based on the advanced solution algorithm solver. So SEISMOStruct have been in the market for the last have been developed by SEISMOSoft for the last 20 years. So this program SEISMOStruct actually have been extensively used and validated by 1,000 users for more than 10 years, and so 20 years. So besides that, our accuracy is well documented, well demonstrated by many success in many what we call blind test prediction exercises. In one of the recent, you can come across a lot of this type of blind test prediction exercise and validation in our verification reports from our website. Later, I will show you from the SEISMOBUILD, our software platforms, you're able to access the verification report quite easily. So regarding on the blind test prediction competition, recently even last year, we have been winning the top in one of the competition in the world. It's called Quick Hot competitions. It's very well known. Every few years they organize a conference. At the same time, they organize this type of blind prediction competition. What I mean by this blind test prediction competition is usually this type of competition they held along with some of the international conferences. Maybe during these conferences they will let the participant visit the lab facilities. So usually before the starting of this conference, they will share this competition with a lot of the questions with all the dimension of the structure, like for instance showing in this figure here. All right, so before they come into this conference, maybe about 6 months before, they will show you the dimension of these structures. So the participant will do the prediction using any software, using any nonlinear programs. So in these particular competitions, a group of students from IUSS, Italy, universities, they're using SEISMOStruct. They attend the competition and they're the winner of the last year competitions. So how they judge the winning is, at the day of the competitions, or at the day of the conference, they will do the actual testing of the real structures. So which of the computational model they can predict the most accurate will be the winners. So we are very, very proud that SEISMOStruct again become the top in these blind test competitions. But over the last few years, we also win a few competitions. I won't be covered today, but if you want to know it more, you can go to our verification reports. Some of the feature of SEISMOBUILD 2020, I summary as follows. Of course, is our main unique selling point is our nonlinear analysis capability. All right, so we are performance-based seismic evaluation methodology based. All right, this is something what we're proud about. We're not dealing with linear, we're dealing with nonlinear analysis. And then another interesting part will be our implementation of strengthening interventions. Implement strengthening intervention or retrofitting intervention is after you do the assessment, you notice that some of the structure might fail or structure element might fail. So you can use SEISMOBUILD to apply your strengthening intervention into it and then reassess the building again. All right. And then how we reassess is you can reassess based on the code defined capacity check, as what I showed in this picture here. And then the general visual interface is extremely very easy. Yeah, later I will show you in our example. you will see very clear that the state of the doing the assessment is very, very easy. The workflow are very straightforward. And some of the feature of SEISMOBUILD is, of course, we can generate CAD details and drawings. This is quite convenient, especially for the typical design office. And of course, last but not least is the technical report generation. Because a lot of time when you're dealing with assessment projects, seismic assessment, you have to prepare a report for your client. So we also have a feature of technical report generation as well. So this is a general overview about this, the feature of SEISMOBUILD. Some of the license types that we offer, actually, if you go into, you can go into check the pricing in SEISMOBUILD online through the SEISMOSoft website. Our license actually is based on a single license, is perpetual license. So we can also offer network license as well, but this is based on the request. All right. So our selling our license will be perpetual. So it's one-off fees. And we also sometimes, time to time, is depends on client. We also offer rental services, rental license from 3 months to 6 months. All right, but usually this type of rental license is suitable for a client that have a much shorter project durations. Maybe they have a one-off project on seismic evaluations. They want to spend maybe 3 months, 6 months. You buy only 3 months, 6 month license. So our license, actually, all the pricing, if you notice from the website, is excluding technical support. Usually, if all my customer, I will actually try to advise for the first year, it's advisable to have our technical support. Usually, we charge about, it's quite low, about 15 to 25% of the software price. For first year, we always try to advise the client to be mandatory, because actually most of the time, most of the questions, when you try to dealing with non-linear, there's quite a lot of challenge, complexity. It's not the same as what you deal with other program, like using linear analysis. So that's why advisable, most of our clients will stick with us for first year. Subsequent year will be usually more optional. For these sections, we actually, for this special Easter holiday, we have some special promotion for the sites for our programs. Later, I will show you at the end of these sections. All our programs is it didn't include any upgrades. Usually our upgrades are offered every 2 years. So upgrade is optional. So usually, if let's say every 2 years there's a new upgrade coming, new feature coming for SEISMOBUILD, usually the user, our customer, existing customer, will only need to pay maybe about 50% of the price of the upgrade, which is very low compared to buying compared to a new customer. All right. Then this all for the general overview of the SEISMOBUILD 2020. I'm going to start with our sections, which is on the seismic evaluation of the 2-story buildings. So a very project overview is by the end of these sections, these exercise tutorials, participants should be able to at least understand some of the basic features of using SEISMOBUILD to model a 2-story reinforced concrete buildings. Okay, and then you'll be able to understand how to conduct a seismic evaluation on building according to ASCE 41, which is quite crucial, and then perform a full procedure non-linear pushover analysis on the structures, assign the capacity of the building, and then later on I will cover very briefly on how to apply a strengthening intervention to the buildings, because we carry out a full pushover analysis. We assess the capacity. Maybe certain elements, certain structure will be inadequate. Then we have to apply strengthening interventions or retrofitting intervention, like for instance FRP strengthening for columns, column jacketing, beam jacketing of the elements. And then after we apply the intervention, then we repeat back the whole process of seismic evaluation and go back to the program again and do the evaluation according to the respective code. So as a general overview, this is the model that we're going to build today. So I'm showing you the front view and the back view of these buildings. We're going to use a SEISMOBUILD building modular facilities. Okay, and then the structure plan layout. This is a general plan layout. If you notice that in my email that I sent to you all, even yesterday, there will be a presentation material. I believe all of you have my presentation slide. And also in the folder, on top of the folder, there's another subfolder that I include the drawings, the CAD, DWG drawings. So there's a two DWG drawing, which is floor 1 and floor 2. D is basically the layout for these two floors, because we will need this DWG later on to do our models. All right, later I will show you how. And then these are some of the details. Later on, we will use this column detail later on to help us to construct our models. All right. So later on, I will come back and forward to look at this table here to try to construct our model, which is our columns. This consists of 8 columns and 9 concrete walls. These are all the details for floor 1s, and this column detail for second floors. And also we included is a beam detail. Beam, we try to, in this exercise, we try to keep it consistently the same. All right, same size with same details. And also same longitudinal reinforcement as well as the transverse reinforcement. And then finally, last but not least, will be the slab details for the whole floor as well. We try to consistently keep it the same slab details. All right. As a start, let us start our tutorial sections on SEISMOBUILD. All right, this interface. Let me exit from my slide and go into the program directly now. Okay. Okay. So when you open up this SEISMOBUILD, this is the first interface you will attain. All right, you will get the first one. So when you switch on the SEISMOBUILD, this is the first thing you will come out. The first dialog box will ask you about please select your structure code and units. All right. So as what I mentioned in my earlier slide just now, SEISMOBUILD are based on the design are based on a couple of few structure codes. This lists out some of the international codes you can use in your model. So in this case here, we are using ASCE 41, but you can use Eurocode number 8, ASCE 41, the Italian standards, the Greeks, and the Turkish. All right. So we will start with the ASCE 41. And also in this box here, we can select what kind of unit you can use. Like for instance, we can use unit, international unit here, SI unit or imperial unit. In this case, I will try to choose SI unit. And the rebar typology is the what type of rebar typology, the rebar size can be used. You can either use the US size or European size. For me, because I'm more familiar with European, so I will stick on the European side. But you feel free, you can use your US size if you're more familiar with that. Okay, let's click OK. So we'll reach our first platform, this interface. SEISMOBUILD interface is very, very simple. The top section here is basically our what we call our toolbars, which is the file, edit. These some of the toolbar which is quite standard, like save, and then we can go into some of the feature like 3D plot to setting our coloring of our elements, and also last calculators, and also some of the button we can access to the SEISMOBUILD help, our user manual. And this one here is a verification report, as what I mentioned earlier. If we click, it will direct you to the SEISMOSoft website. You can download a full report. This one will be quite interesting. You can download the full report, how we validate our programs. So this program is already fully validated, and also some of the blind test prediction competition in the past, some of the interesting prediction we've done before. So you can go there, have a look. And we also, in the next button is showing the sample files, some of the sample files you can refer, and then you can also go to the SEISMOSoft forum. You know, there's a lot of very active forum. Any question you have in this program, you can feel free to submit your questions. They will be whether myself and also some of the experts from SEISMOSoft, they will be able to help you. And so you can also email, and you also, of course, the SEISMOSoft website. And then in this bar here is basically the toolbar here is basically for the, like for instance, the display layout. You can choose what kind of layout you want. Because we still haven't created a model yet, actually we cannot see anything. And also some basic display setting, like showing the the member names, show the foundations and so on, exit and grid line and so on. All right. So, and this one is basically cut plan. Is basically you view the structure and in which exit or which cut you want to look through, whether you want to displace the member, beam or column and so on. Okay, so very simple. And at the left hand side here, you can see that this bar section here, this toolbar section is what we call the procedure steps. So in using SEISMOBUILD, it's quite simple actually. Our workflow is starting from top to bottom. So basically, there is about 6 steps. You have to go through one step at a time. We start with the building modeling. After you building modeling, then we will go to the next subsequent steps to do to complete the whole assessment. All right, because later on, let us start with the building modeling first. Later on, I will come back to each of the steps again. All right, I will start with the building modeling. So if we to start the model is very simple. You can either open your existing file, okay. If let's say you already done some previous job in existing file, but in this case here, I'm not going to do that. So I will straight away go to the building modeling because I want to build the model from scratch. So I click the building modeling. Straight away, it will transfer us to the next interface, which is our building modeling building model interface of facilities. But before you can go there, is for every new models, they will ask you, they will have some initiate the building modeling. There will be some modeling setting you have to set. Like for instance, how many story you want to create 3 story, 4 story until 100 stories maximum. So in our exercise here, we only 2 stories, so we select 2. So you can see is when you increase the number of story, the number of story height also increase. You can see that below here. So it's quite easy. You can select for each of the floors, each of the story, what's the height you want to put in. So in this case here, we put 2. Okay, and also the underground, we also allow a user to try to include the basement contributions up to maximum 3 basement. You can try to put in. All right. So in this case here, this example here, we don't have any basement, so we try to put 0 in our case here. So this is our first setting. The second one here, you go to the next tab, you can see is the structure modeling. Structure modeling is try to model some, try to setting some of the basic, like for instance, the frame element modeling. Try to, this is a dimension we already set 0.1. What it meant is, if any dimension that is less than 0.1, they won't count it as a beam. All right, so only any elements that more than 0.1 we consider as a beam elements. So we set 0.1 as a by default. And in terms of beam modeling, we include the effective width calculations, control nodes, they're all some automatic and so on. We keep everything the rest as a default. So once we got our first setting, we can click OK. So it will transfer us straight away to the SEISMOBUILD building model facilities. All right. So now we go into our building model interface, the facilities. You can see that this interface here, we're going to use this whole interface to generate our models. Some of the features, I think is pretty much quite standard. Self-explained is like file, save. Then we will start with this middle toolbar here. This is where, like, for instance, how to insert the drawings, moving the structure elements, and to delete the elements. Then below this toolbar here is the insert different type of shape of the structure elements. Like we can insert rectangular column. Every time we click the rectangular columns, there will be some this box explaining to you how to do it. So this section property will come out with explaining. You can put in your section property to insert the columns. All right. Later I will explain this one in more details. And also in the left hand side here is the snap tools. We can snap any of the object to the drawings, or to the object, to the grid line, and also auto. All right. And this one, this toolbar here is to try to explain about it's zoom facilities. You can zoom in, zoom out, and or zoom to the windows, and zoom to all. So some of the feature we can do is we can insert column, we can insert rectangular column, square column, we can insert L-shaped columns. We can insert T-shaped columns. You can see that T-shaped columns with the rebars. We can even insert circular columns. In this case here, you can see, and we can insert the walls. Okay, and this is a beam, pretty much beam. All right, with all the rebars. And then this part here is a jacket rectangular columns. This one is more for our intervention. We will do it in our second part. For these particular sections, these are our original, let's say for instance, these are our original sections. This one is our new sections. Jacket column, jacket rectangular column, jacket L-shaped columns, okay, jacket circular columns. You can see the rebar as well, and finally, and also the jacket beam, okay, beam elements, beam sections. All right. So we also can, in this tab, next one tab here, also insert for the slab, and also this tree function is to help you to insert your slabs elements. And last but not least is insert of the staircase. Staircase is something based on our how to say, our experience is some of the old structure. If you include the contribution of the staircase also help indirectly to help you in terms of the seismic performance of the building. All right. So as a start is, let us start with our first model. So to do that is, what we're going to do is we're going to insert our DWG drawings into this interface. So to insert that, you can go to this button here, is import DWG. All right, if you click this button here, you will come up with a box you can go to find our drawing. In this case here, I already saved the drawing in this folder. So because we're going to start our floor, our modeling, our building one floor at a time. So we will start with floor number 1. All right, these are our DWG drawings. Once you select floor number 1, you click open. So the first box it will come up is an import CAD setting. So you have to, based on what you need, you draw in your file, like whether it's mm, cm, or meter. So in our drawing here, we are based on meter, so we put meter there. And also we try to move it to the origin point 0, 0. That will be a lot easier for us to work with. So we click done. So it's basically able to insert our DWG drawing directly to this interface here. All right, you can see that. So you can, this what insert here. If you don't want, you can try to hide it. You can show and hide the drawing. If you don't want, you can show, but you can hide. Okay, so in this case here, we will start to construct our building, our first floor. We will start with constructing the column. All right, the column, which is this, is basically 8 column here. We will start with the first column, which is insert rectangular column. Every time we click the column, it will come with this. We're explaining to you how to insert the columns. If you don't want, you can switch it off. Okay, we will start with our first column here. If you go into our lecture notes, in one of the presentation material, the column details for the first floor or second floor, you can see some of the detail there, all the column size, the rebar size. So like the first interface, what you come across here is, there's 2 tabs. One is the view and modified geometry. This is what the geometry is. And secondly is a view the rebar. We will start with the first one first. Because for the first column here, if you zoom in, have a look, C1 and C2 is basically the same size. It's 400 by 400. So you can choose these 2 types of standard sections, either rectangular or square. You can choose 400 by 400. Straight away you can change the dimension to 400 to 400. Or if you want, if you prefer, you can type in any dimension you want. Like for instance, I want to put 600. It's possible as well. So you can either type in the exact value of the size of the column you want, or you can choose from the standard section from these 2 tabs here. So in this case, we choose the standard because it's a standard size, 400 by 400. And also in this exercise, this tutorial, there will be some what we call foundations. The foundation, the top of the foundation to the finished floor levels is about 1 meter below the floor levels. So we have to put in the top of the foundation level. In this case, it's 1 meter, so it's negative. It's below the origin point, so it's negative 1000. Okay, it's in millimeter in this case here. All right. Okay, so it's negative 1,000 per meter. So the section size is 400 by 400. Let me move this one up here. All right, so once you define the section size, the next one is to define the longitudinal reinforcement. So you can see is when I select this part here, it straightly change to the view reinforcement. So in this particular column, the size of the column, we can choose what is the number of the bars and what kind of size of the rebar we're going to provide. In this exercise here, this C1 is basically four number of 18 mm rebars. You can see that every time when we highlight, like for instance, I select corners, this corner bar will be highlighted to yellow color, indicate that you already did this the particular item that we highlight. All right. So in this column here, there is no any top, there's no any side rebar, so we can set it as 0. Okay. So, and also if you go to the next one, the transverse reinforcement. The transverse reinforcement in this one is basically 8 mm rebar size at a spacing of 200 millimeter or 20 centimeter in this case here. So you can see that similar to longitudinal reinforcement, once you highlight the transverse rebar reinforcement will turn to yellow color. So, and below here, you can even define what's the number of legs. Like in this case, there's a 2 leg in that cross sections. In the height, you can increase to 3 leg, 4 legs. It depends on what's your detail, what's your design. So in this case here is 2 leg. The width also can do the similarly the same. So width and the height is the same, is 2 legs. And also once you got defined the reinforcement, we can also got a setting for you to define what is the material set. So if you can define the material set, if you click the material set, there's a list of the property here. By default, you already define what is the property value, but you can change it. You can either change by double click here. You go to this table. You can change the name if you want. You can put in a new material set if you want to. We will start with this default existing. You can define about what is the concrete strength you want to put in, what is the concrete strength for the steel, for the concrete and the steel. All right. And you notice that is for the modified existing material scheme, we got one special button here. Actually, this button here is only applied for ASCE, ASCE 41. For Eurocode, we don't have. If you click there, is based on the ASCE 41, they tend to define the history, the time frame of the history of your structure. Depends on what kind of structure elements and what kind of time frame. Is it your building was built during 20s, during 50s, during 60s, or during 70s? It will be a defined value about the strength of concrete and also for the strength of the steel. All right, so this one is quite valuable. It's only applicable for the ASCE 41. All right, cancel. In our case, we're not going to select this one. We are going to select based on our pre-selected values. So this one is based on existing. You can also define what sort of new models, new concrete strength value you're going to put in. All right, so you can see same as concrete and also for the steel strength. So usually it's like if you're doing the seismic evaluation for existing building, usually we use the existing members. So if you do the concrete jacketing, that after you define the existing building, you want to repair with concrete jacket. The concrete jacket, the new concrete is based on the new material. So that's why by default, you already default these 2 values. But if you want is you can add in your own concrete material as well and type in your own name. And then you define whether it's existing or new. All right. So in this case here, we're not going to change anything. So we cancel it, come out. Then the next bar here is FRP wrapping. FRP wrapping, for the first stage here, I'm not going to do anything, but this one is more on defining what kind of FRP system we're going to use. All right, so I will skip this part. Later on, I will explain this after I finish the assessment of the building. All right, so we can define the FRP wrapping. Then we can also go into the advanced material property. Okay, so this one here, you can define about what's the classification of your member, whether it's primary or secondary. If you look into ASCE 41, they define that. Primary is the primary members that supporting the seismic actions. Secondary member is more for the non-structural elements. So you can define what kind of classifications. the longitudinal types, the lapping, the length of the lapping, and also the accessibility of the area of interventions. And last but not least, is quite important, is a concrete cover. You can define what sort of concrete cover in your section. So we can come out from here. And finally, the last one will be the modeling parameters. Modeling parameter is based on, in this case here, we select the default. It's based on what kind of concrete model you're going to use. So these are some of the concrete model you can use in your for concrete, for steel, and these for what kind of element classes, the frame element modeling. So some of the different type of element you can consider in your modeling. And also some of the other settings like section fibers and also release the moment and so on. You can do it in this part here. But in this case, we're going to keep it as default values. We're not going to change anything. So once we have we're happy with all the settings, we can go to the view and modify geometry. Then we can start to insert our column. So you can see that is this column here. You notice that there's 9 points. This point here is what we call the insertion point. Is how you're going to insert into your DWG drawings. So in this particular example here, I want to choose my point. My insertion point is this corner. All right. So when you insert, is this corner must match exactly to the exactly corner of these drawings. So in this case, before you insert, try to switch on your how to say the snap to DWG function, the tool button here. So you can see is once I move my mouse cursor to here, straight away there will be insertion point. Because I already select the insertion point in this corner here at the left bottom corner. So I insert here and click insert. Straight away they insert the column for you directly. Very simple. Similarly for C2 as well. I click this corner here, it will insert the column for me. All right. So now we move on to the third one, the column C3. So for column C3, the size in this case here is slightly different. Is 250 by 750. You notice that is when you insert column 1, column 2, this numbering also changing for you. All right, it's automatically changed for you. So column C3, the size is 250 by 750. So we can go to rectangular, choose exactly this column size here. All right, so it's 250 by 750. Okay, foundation depth is still the same. Okay, so we go to the longitudinal reinforcement. In this case here, if you look into your detail, is you need to provide four numbers of 18 mm size rebar at the 4 corners, and also in the how to say in the left, in the top and bottom, we also need to provide 2 extra rebar, which is the size of 14. You have to refer to our presentation material. This is the size of the rebar we provide for column C3. And the rest of the detail, like for instance, longitudinal reinforcement is the same. The rest of the material setting, all the advanced material properties and modeling parameter, we keep it the same. So once we're happy with that, we go to the insertion point. So in this case here, this column, maybe I will try to change the insertion point to this column, this corner here at the right bottom point. So move in here, we can insert directly here. So it's quite simple. So while we're doing that, we can move on to column number 4. So you can see that column number 4, the section size is 300 by 500. Let us go to 300 by 500 standard size. All right, you can change if you want. And in this case here, you notice that the column, the orientation is what I show here is in horizontal, but I will try to, you can try to use this function at the top here. You can change the orientation you want. You can see, change to all 360 degree. In this case, we try to put it in horizontal, vertical 300 by 500. All right, and then the rest of the setting is the same. And the rebar in this case here will be it's a 418 mm rebar at 4 corners, and the 2 rebar here will be same, 2 number of 18 mm. Okay, this is the size of the rebar for these sections, and the transverse reinforcement are all the same, and also the rest of the material are the same. So we're happy with that. we do the insertion point. In this case here, we can try to put my insertion point at this corner here. So I go down to this column, then insert. I notice that is for column C4, C5, C6, and C8 are all the same details. So we apply the column. In this particular column, maybe I change to this end here to make it easier. Okay. So once we're doing finish the C6, we can do the C7. You can straightly jump to C8 if you want, but we start with C7 first. C7 is, I think the section size slightly different. Now in this case 250. Let's change using this. We change to 250 here. We move down to 250, and the size of the rebar is slightly different as well. In this case here is four numbers of 18 mm bars and two numbers of 14. In this case here, slightly smaller. So we change to 14 mm size of the rebar. The rest of the function like transverse reinforcement are all the same, and also the material set and also the rest of the property are similar. So we're not going to change anything. So we move to this column C7, then we insert here. Try exactly match with the insertion point. So it is column C7. All right, this is 250 by 500. And then now we move on to the next one. The next one is column C8. So you notice that is column C8. Actually, it's the same detail, but it's in the inclined position. So what I'm going to do is I'm going to use this. I select one of the previous. I know that is C8 have the same detail as C4, C5, and C6. So I click C4. All right. So straight away in SEISMOBUILD is the last mouse click section that you click will be the same property already save it here in your section property box. So once you click this one, then you click column. So you can see that all your details C8 is already here. All right, the numbering C8, the section property, all the details are the same. Is exactly for C4 detail, which is exactly the same column that we want to insert. Same column detail that we want to insert. So in this case here, you can see the rebar is exactly the same section. Same longitudinal reinforcement details and the same transverse details. All right. Okay, the way how we're going to do the insertion point is, you notice that is this column is inclined. So we're going to change our orientation to this corner. All right, and then we put our insertion point here in this angle. If we put where is our insertion point, and the angle will be based on the rotation point. So in this case here, I already worked out the angle is about 11 degrees. So I type 11 degrees. So you can see that is already rotated in 11 degrees. All right. So, and then you go into this drawing, you can put the insertion point this point if you want to. So I'll try to put the insertion point at this point, and then I insert here. Yeah. So this is how we insert the column with inclined orientations. All right. So in this case here, we already finished all our columns. The next one I want to show you is how to insert a wall. So in insert a wall, you go to the insert a wall dialog box here. Okay. So the wall in this case here is 1.8 meter by 250. So this is a wall. The section by default already give you 250. This is the width of the sections. The rest of the detail, like it's the same as a column. There will be top of the foundation top level will be 1 meter below the floor levels. And also your reinforcement detail for their walls, if you go into my slide, it will give you the detail of the reinforcement. In this case here, we need to define about what is our reinforcement detail. Let me scroll down here. You can see there is two corners. The corner means is a corner of the studio columns here. These two columns. So column 1 is the left hand side. Column 2 is the right hand side. So similar to column, it will highlight once you select the bar, you will highlight the details. So let us start with from this column number 1. If we look into our detail, is 4 16 mm bars. So we change to 16. Okay. And then in this particular example here, the weak axis, there is no, I don't think there's any rebar in this size. And then in this strong axis here, there is two number of 14 rebar here. Okay. Same as the other corner as well, is 416. And there is no rebar at the weak axis, so we can put it 0. And the size along the strong axis is 2, and is 14 as well. So select 14 here. All right, so we already defined the two pseudo columns details. Now the middle one, if you notice the middle rebar, which is highlighted in the middle here, we're going to provide 8 numbers of 8 number of 8 mm bars. So we go to select 8 mm bars, 8 number of bars. So we select 8 here. So it will be well distributed top and bottom. All right. So we're done with our longitudinal reinforcement. Now we move on to the next one, is a transverse reinforcement. So transverse reinforcement in this example here, we also provide the same as our column. So it's 8 mm at 200 mm center to center. So 8 mm, so change to 8. So it's 200. It's 20 centimeter. Similarly, for the other edge as well, you can see that every time when you select which side, which edge, the particular link detail will highlight. And this one is a 20 cm. Okay, 20 cm. The internal grid is the same as well, 8 mm and 20 centimeter. So similar to column, you can put in how many legs you want. Like this one is how many legs you want to put in, how many legs you want to put in at the height and at the width. So in this case here, we don't need, so we'll put it 0, put it two legs. Same as the middle part here as well, you can put in how many legs for the middle sections. So in this case, we try to keep it by default is 2. All right, so we done the reinforcement. The rest of the setting is the same as column. We keep it as by default. We're not going to change anything. So now we're going to show you how to insert the wall. So for the wall is, if you look into this wall here, you notice that there's a 3 parallel line. This parallel line indicate that is the line of how you insert the walls. So in this particular wall here, you can either insert at the middle line here, but in this particular example, it will be easier. We start from the corner. All right. So if you select either this which line you want, and for instance, I select the top line. So I will move here. From here, I will click my wall. All right. Then, because you notice that I already select this snap to auto is on, so I switch off. Then it will be, following the line here. So we can select the next line. You click. This is how you insert the wall. It's very simple. All right. So if you select this select element button here, you go to select this wall. These are the property in the wall. You can double check back again if you want to. And in this wall here, you notice that the dimension is slightly on the way here. We change back to 1008. All right. So there's a 2 setting you can do. You notice that is the length you can change, and also here, this is what we call the pseudo column width. What I mean is this width here, the width of this particular column. So if I'm not mistaken, if you look into the standard, usually the way how we calculate the column width is 1/5 of the length of this wall. So just now we already changed to 1006. 1/5 is 1008 divided by 5 is about 360. All right. So you can see that this is a 360 width of this pseudo column width. We can set that. All right. So now we're done with our walls. We're going to move on to our next section, which is we're going to insert our beam. So in our beam here, we can go to this function. You notice this function here, insert beam. Okay, so we can try to insert our beam detail. To insert our beam detail, you notice that is our beam section size in this example here is 200 by 500 mm. So we can select, in this case, we can select straight away from this standard size, 250 by 500. All right. And then we can go to the reinforcement detail. In terms of reinforcement, you notice that is we divide it into 3 sections. One is what we call start, middle, and the end. In my PowerPoint slide, I try to draw a schematic diagram explaining the meaning of it, because in most of the case we're dealing with reinforced concrete, it's always cast in situ. So the start will be the start of the one end of the your beam, which is connection to the column. The other end is another end for another column. Middle is the main middle rebars. All right. So this particular example here, your beam, your start will be provided with 3 numbers of bars. Okay, 3 number of 14 mm bars. Okay, for the start, and the upper bars here. Oh no, sorry, the lower bar is 2. Okay, the upper bar is 3. The size is 14. Okay, so in this example here, we don't have any side rebar, so we make it 0. All right, keep it 0. All right, so it's 3 at the top, 314 at the top, and 214 at the bottom. So we move to the middle. You click the middle. Middle actually is here. Middle at the lower part will be 416 in this case here, and the top is 214, similar, and the side is actually 0, again 0. So the middle part is double check 214 and 414 here. Then we move on to the next one, which is the end. End will be here. You can either click here or you can go here directly. You can click here directly, it will change the button for you, change to the end. So end will be, the detail will be similar to the start. So will be 214 and 314. In this case will be 0. Okay. So this is a detail for the end, detail for the start, and detail for the middle. All right. Similarly, we can do the same thing for defining our transverse reinforcement. In this case here, our transverse reinforcement same as the column. Actually, we are 8 mm by 200. So we change all to 8 mm by 200 here. 8 mm by 200. Same as you can select what sort of link, how many legs of link you need to provide for your beam. You can also include additional permanent load if you want to, but in this case we don't want to do that. The rest of the parameter and setting we keep it the same. So I will show you how to insert the beam. The beam is actually, you can go back to here, same as how you do with the walls. There's a 3 parallel line to decide where is your intersection point. So we start with beam number 1. Let's say we want to insert beam number 1 and 2, which is here, these 2 beam here. So usually we don't need to go to column by column to do the insert. The beauty part of SEISMOBUILD is what you can do is, I can show you, if I insert based on the bottom line here, I select from one column to another column here. So in the notice is the program straight away will detect there's a 2 beam. You do it for you, very instantly and very quick. So we can do, since all the rest of the beam is the same, we can do it the same. So let me do in this case here from, you can see from bottom here to the top. Okay, straight away from here, it will break down into 3 beams for you instantly. Okay, so same, I want to do the other beam here. I select from this corner here, straight up to here. It straight away break down for you 2 beams already. Okay, and then we can do it something similar for this beam as well. To the top of the wall here, in this case here, so it will insert straight away 2 beam for you as well. And this column as well, for this particular column, maybe for this particular beam, I insert from this column until the end here. And this beam from this end to this end. So you can see that the insertion of the beam is very, very straightforward. For the inclined part is similar. We will start from this corner here, like this corner here, and straight to the other end here. Okay, so how we insert the beam. Very, very simple and very straightforward. All right. We notice that there's two extra, this beam here, these small elements. It's not contributing. Let me delete it out. Okay. So this will complete the whole insertion of the beam. The next step, what I'm going to show you is to insert the slab. There's a couple of few slabs here. You notice that? The slab function is very simple. You select to this button here, insert slab. If you click the insert slab, you come up with this button here. The first thing it will ask you is what is the height. So the height we know that is 150, so we keep it as 150. Then we can define about what is the size of the rebar. So if I'm not mistaken, the rebar is 10 mm size by 150 mm center per center. So you can see that is once you define the thickness of the slab, is the permanent load is auto calculate for you. You see, you can auto calculate the permanent load based on the cell weight of the slab. You can click here, you can let it auto calculate, or you don't want, you can insert your value yourself. In terms of the live loads, you can based on what kind of type of live load you can refer to here, like what kind of occupation function of the building. Is either theater or dining hall, fire escape. You can put all your loading here according to the ASE. All right, in this case, I use the default, which is 2 mm. All right, we also got a function to insert slab inclination, but this function I will show maybe in our future webinar. So once you have defined the slab, you can insert it. Insert the slab is very simple. When I click this function insert slab, as long as there's a boundary condition of all with the beam and the column, we click here, we straight away insert the slab for me. You can see that insert the slab for me instantly. Okay, so if you choose after that, if you select this button, select element, you pick one of the slab. You will notice it is these two table here. You already straight away got the what we call the support condition, the green line here. This support condition indicate that this particular slab, what is a support condition? Green line indicate that it's supported. It means it's fixed. But you can choose that you want to release it if you want, also can. You can see that if I click this beam here is beam number 3, it becomes supported. If you release it, it becomes free. All right, so we got a function to let you release the support condition of your slab. But in this particular, we try to keep it supported. All right, so now we have done our first floor models. All right, so what we can do is after we done that, we can go to this function, view the Storey 3D model. This is quite useful. If you click that, it will generate the 3D model for you to see whether your model is correct or wrong before you move into your main platform of your SEISMOBUILD. So you can see that this is a floor of our first floor here. All right. So everything looks okay, looks fine. Everything is well, exactly what we're looking for. All right. So we've done our first floor now. Now we want to move on to do our second floor. So if you go to before we do the second floor, we can I want to show you this function here. You can see this floor with first and second floor. You can select which floor you want. Like this one, what we show here is the first floor. If you select second floor, actually there's nothing there because we haven't created the second floor. Okay, first floor and second floor. So for second floor here, we want to insert a new drawings. Okay, because this drawing is based on our first floor drawings. So we go back to this function again, import the DWG. We select the second floor drawing. Okay, we insert, and same function will ask you what you need, the original point 0, 0. Straight away, this is second floor DWG drawings. All right, but before we do that is because many of the detail is the same. So what I'm going to do is I'm going to copy the detail from the first floor to the second floor. So I go back to the first floor. Okay, and then if you notice that is this function here, copy floor. Is very useful and very powerful. If you click this button, you can see that this button can help you to define. If let's say you come across a project, if every floor are the same detail, you no need to repeat it. You just finish one floor, just copy outward all the details. So in this example here, I'm going to show you is I want to copy the floor from number 1 to number 2. All right. So if I click OK, so it's straight away copy for you already. Now, if you move to this button to floor number 2, you notice that the floor detail already copied. If you go into 3D model, the structure model, you will notice that is the 2-story already show for you. You already copy it directly for you already, straightforward. All right. All right, so once we're doing that, we go to the second floor. We need to make some slight changes, because if you notice that is half of the floor actually is not there. We had to change the detail of the second floor. So if you notice that after we insert the drawing for the drawing in the second floor actually, later on I will do the adjustment, but we need to delete some of the detail here. So what we do is we can use our delete function, delete element here. So to delete the elements, there's a few. You can either use delete by rectangular selections or delete by elements. So in this case here, I'm using rectangular selection. You can see every section that I select, return to pink will be the section that I want to delete. Then you click delete here, you straight away delete. If there's another way you can do the delete is you can select the members. Like you can select this one, select this member, you straight away delete for you. So it's very, very simple. All right. So once we do the delete sections, we can go back. We want to make, you notice that this building here, there will be another cantilever slab. And also you notice that is the drawing are not in line. So how we're going to do is, we're going to move our drawings. There's a two way you can do that. First thing, you can select this function, move the exit center. Once you select this function, you notice there's a red dot here. You can move the structure to exactly in line to this building. Okay, there's one way you can do that. There's another way is, which is I quite more prefer to use this one, move DWG. If you click this button, you can move the DWG. So it can go from the baseline, which is baseline is where the base where you want to go. The second point will be this point here. Then you move, it straight away move for you. I think this way will be more precise actually. All right. So once the drawing and the model are in line to the drawings, we can start making this cantilever slab. So to making this slab is quite simple, because in this case here is a cantilever slab, and then there's no edge beam along here. So it's not possible to use this insert slab. So what we're going to do is we try to insert the slab edges. Click here. This function is quite useful. Usually we use this one for making this type of cantilever slab or making for staircase. So we have to define what is our slab edge. The edges is we can start from bottom, like this line here. Okay, we click all the edges that we want to insert here and here. Then once we're happy with that, all the edges, we click apply. You notice that is it will turn to a blue line here. All right, once you turn in blue line, you go back to our slab. We can select this element, because we want to copy, we want to have the original section property detail, which is the thickness of the slab, and also the reinforcement detail. Then we select insert. You can see all the detail are the same. Okay, then we select here. Straight away it insert the slab for you directly here. So similarly, just now you can see that is the support condition, because this at the edges here is a free end, so it shows a dash line, a dot line here, a dash line, and the green line representing it connected back to this beam here as a cantilever. All right. So once we finish this one, we can have a look at the 3D view of the models. So we can see that the building already done. So we already done our 3D models. We are cantilever slab here. Okay. So once we're doing that is we're happy with that, we can come out. Then the next step is, if we're happy with this model, we can exit this model to the SEISMOBUILD interface. So what we do is, before you can exit from there, we need to save a file name. Let us save to tutorial 1. Okay, is our file name. I click save. So it will then transfer this model straight to the SEISMOBUILD main interface. All right, so you can see that this model will directly transfer to here already. Okay, so this model already done. That means we already create these 3D models. So now is we can start to do our seismic evaluation now. So as what I said just now, the step for doing evaluation actually is from top to down. This is a workflow. We have already done this building model. You can go back, click this button to go back to this model to make changes, but we don't want to do that. Once we've done all this model, we can go to the first step, which is the code requirements. All right, this code requirement is quite important. It's where you define what is the seismic evaluation code requirements inside. So you can choose from Eurocode, ASCE, and Italian code, everything lah. As based in this exercise, in the starting of this program, I already select ASCE 41. So by default, you will come up with this performance level based on the ASCE 41. So if you're familiar with the ASCE 41, there's a different type of like building target requirement you can select, and also based on your seismic hazard levels. All right. So you can select about your performance objective. These all based on the requirement by the ASCE 41. So the most basic one actually is the ASCE, what we call BPOE, Basic Performance Objective for Existing Building. You can select this one as our most basic. Usually, you try to go to more enhanced objective. It's based on if you want to study in more details, and also can be due to your client requirements. So in this particular example, I only select this basic performance objective for existing building based on the performance level of life safety and collapse prevention. I will try to select another one, which is here, to include the intermediate objective. If you want is, you can insert another one. You can study all the 4 limit state. All right. So for this particular example, maybe you can let you try it yourself, but I will choose only these 3. Okay, the first thing, this one will be the performance levels. Secondly is the analysis type. So we are going to, in this example here, we're going to do the analysis based on nonlinear pushover, so static procedure. So by default, they already set the inter-story drag is 2%. The pushover analysis step is 50. And then we can define about what sort of standard combination, like you can based on the ASCE or based on the basic combination. You already select the first 8 for you. All right. So for me, I try to select this ASCE requirements. You can see that they are based on these requirements. It's based on single eccentricity, 8 cases. It's all based on the model case. We can try to select these 8 cases. It's okay. But if you try to select all, you notice that is this number 168. So there's quite a lot of combination to finish it. All right. So I think for quite limited time, I try to select maybe only 8. Sometimes I will also, maybe I try to keep it, maybe try to select, maybe let us try to select these 8 cases. All right, so once you select all the 8 cases, the next step is select the knowledge level. Knowledge level is based on the level, how much level of knowledge you have on your structure. So there's a 3 level based on minimum, usual, comprehensive. So I will choose usual. So the level of knowledge you have to refer to the ASCE 41. And also seismic action. This one is the default seismic action for ASCE. You can choose based on what kind of ground condition, A, B, C, D until E. In this particular case, I choose soil class C. And you can based on the code base, or you can based on user define. You can define about the parameter you want. Based on what kind of requirement you want to put in, you can define that yourself. In this case, I'll try to use maybe code base, and then static action, the coefficient. This one I use by default. This one is based on the ASCE 41. All right, and also this part here is the check. What kind of check I want to carry out? I carry out based on the standard check. This is the moment core rotation and shear check. And also in this button here also include a safety factor. You include all the safety factor for different codes, but in this particular is ASCE 41. In Eurocode will be a lot more. You can see Eurocode is a lot more detailed. This ASCE 41, we click OK. You don't change it. So once we're happy with all the requirements, we can go to the next step now to do our analysis. In our analysis, there's a 2 type analysis we have to do. We have to do our eigenvalue analysis, and we do our pushover analysis. So before we can do pushover, we have to do the eigenvalue. So once you click eigenvalue analysis, the first button they will call you to confirm to save your model. So you have to say yes. Okay. So you move into this table, which is our eigenvalue analysis. All right. So we can click run analysis. Once you got this dialog lock, it means that your model is already complete the analysis quite quick. So you can see that is once you got the complete the hydrogen analysis, you can see your result. You can view using your result here. So eigenvalue analysis basically it calculate all your fundamental modes, the values, the frequency, and your different modes. So you calculate the 10 modes. So you can see that in this diagram here, this one is the first mode. All right. So you can try to emulate this structure. Okay, this one is the based on the first mode. This one based on the third mode. The different emulate of this structure, and this one is sixth mode. You can see that you can do it for you quite easily. And also, you can the analysis also complete all your model periods and frequency. Already calculate for you the model participation factors, which is quite important. The effective model mass.